There is a mathematical argument in physics known as the Cosmic Shoreline. It suggests that our universe isn't perfectly designed for life, but is instead barely tolerating us. We're living on the edge of a razor, where the physics that keep us alive, gravity, time, and light, are also the walls of a prison. For decades, we have looked at the stars with what J.R.R. Tolkien called a sea longing, a compulsion to cross the ocean of space. But every time we try to leave, we hit the same three invisible walls: the speed of light, the energy crisis, and the expansion of the universe itself. Most people think we are just waiting for better technology, but the math says we might actually be trapped. However, a new paper has proposed a way to slip through the bars. It does not require giant lasers or magic physics. It uses a maneuver so dangerous and precise that it reminds us of a certain docking scene in the movie Interstellar. It is called the Sun Diver Maneuver, and it might be our only ticket out. To understand the escape plan, you first have to understand the jail cell. Our first lock is distance. Chemical rockets are simply too slow. Even with our best engines, we are trapped by the tyranny of the rocket equation. The billionaires and physicists behind the Breakthrough Starshot project tried to solve this by proposing a light sail pushed by 100 gigawatts of lasers. It was a brilliant idea, but it has a fatal flaw. It requires a battery the size of a nuclear power plant and a budget that likely exceeds the GDP of most nations. Because of that cost, dreams of interstellar travel have largely been crushed by practicalities. We realized that the cavalry isn't coming to save us. But what if we didn't need the giant lasers? What if we could steal the energy from the biggest battery in the solar system, the sun itself? This is where the new concept comes in. It is called TARS, which stands for Torqued Accelerator Using Radiation from the Sun. Instead of a simple sail that just gets pushed away, imagine a giant tether, like a giant baton cartwheeling through space. One side is silver, the other is dark. As it sits in sunlight, the difference in radiation pressure causes it to spin. It acts like a mechanical battery, storing up incredible amounts of rotational energy over time. But here's the trick. If you just left it there, the sunlight would push it away before it got fast enough. So we have to cheat gravity. We put this spinning machine into a special path called a quasi-orbit. This balances the outward push of the sunlight against the inward pull of gravity, allowing the device to hover and charge up its speed without flying away. It spins faster and faster for years until it reaches a critical velocity. Then, at the perfect moment, the tether snaps. It releases a probe like a stone from a sling, shooting it out of the solar system at thousands of kilometers per second. This is the engineering of the impossible. But escaping the solar system is only half the battle. Once we're out there, we face the second lock: time. You see, speed and time are the same thing. As we learned from the twin astronauts Scott and Mark Kelly, moving fast actually changes the flow of time. Scott spent a year in orbit moving at 17,000 miles per hour and came back 5 milliseconds younger than his twin brother. That's a tiny difference, but if this TARS system works and we start moving at relativistic speeds, we begin to time travel into the future. If we could reach 99% of the speed of light, a single day on the ship would cost us 197 years back on Earth. We aren't just exploring space, we're exploring the future. And that brings us to the final and most terrifying lock on our prison cell: the dark sector. We used to think space was empty, but we now know it's filled with an invisible scaffolding called dark matter. It holds galaxies together like a cosmic spiderweb. But it has an evil twin called dark energy. While dark matter tries to pull things together, dark energy is pushing everything apart. About 5 billion years ago, dark energy started winning the war. It's stretching the void, pushing our destinations away from us faster than we can reach them. This leads to a scenario physicists call the Big Rip. Eventually, this expansion could become so violent that it rips apart galaxies, solar systems, and even atoms. This is why the urge to leave, that sea longing, isn't just a romantic dream, it's a survival instinct. The universe is changing. It's becoming a cold, desolate place where the lights are slowly going out. We're living in a universe that might be statistically designed to be hostile to life, but that hostility is exactly what forces us to innovate. We don't build machines like TARS because it's easy. We build them because the shoreline is eroding. We are the outliers who refuse to accept the speed of light as a prison wall. We're still limited by the technology of our time, just like Howard Stark said, but the blueprint is here. We have the math for the escape. Now we just need the engineers to build the ship.